requirement for wrapping rigid metal conduit, or RMC, in corrosive soils stems from the National Electrical Code, specifically Section 352.10b. This section mandates that raceways and fittings be made of materials approved for the purpose and installed to minimize corrosion. It also specifies that they must be of sufficient thickness to withstand encountered conditions and be protected against corrosion. In concrete, raceways should be placed in rigid conduit or embedded in at least 2 inches, which is 50.8 mm of concrete. The National Electrical Code, NEC, is developed by the National Fire Protection Association, NFPA. It serves as the widely recognized standard for electrical safety in the United States. The NEC is crafted through a consensus of experts in the field, regularly updated to incorporate technological advancements and best practices. The authority having jurisdiction, OJ, typically a local building or electrical inspector, enforces the NEC within their jurisdiction. The AHJ interprets the NEC and can establish specific requirements based on local conditions and ordinances. While the NEC doesn't explicitly detail wrapping RMC in corrosive soils, it mandates raceways and fittings to be corrosion protected. The practice of wrapping RMC with 10mm tape in corrosive soils likely originates from local ordinances or industry best practices. Wrapping RMC with 10mm tape provides a protective barrier against corrosive substances present in the soil. This tape helps prevent direct contact between the RMC and the corrosive environment, minimizing the risk of corrosion. Besides wrapping, other protective measures for RMC in corrosive soils include firstly, using stainless steel or aluminum raceways. Secondly, installing a cathodic protection system. Thirdly, coating the raceways with a corrosion-resistant material. And fourthly, burying the raceways in below freezing depths. The rationale behind the wrapping of RMC lies in the properties of corrosive soils. These soils contain substances that can degrade metals over time, leading to structural weakness and potential failure of the conduit system. By providing a physical barrier, the wrapping mitigates the direct exposure of the RMC to these corrosive elements, prolonging its lifespan and ensuring the integrity of the electrical system. The choice of 10mm tape as a standard wrapping material is based on its balance of durability, flexibility, and cost-effectiveness. It provides a sufficient thickness to resist punctures and tears while conforming to the shape of the conduit for tight seal. The tape material is typically made of polyethylene or polyvinyl chloride, both of which exhibit excellent resistance to moisture and chemical degradation. When selecting a tape for wrapping RMC, it is crucial to ensure that it is specifically designed for underground use and is compatible with the type of soil in which the conduit will be buried. Some tapes may contain additives that enhance their resistance to specific corrosive agents commonly found in certain soil types. Prior to wrapping the RMC, it is essential to thoroughly clean the conduit surface to remove any dirt, grease, or other contaminants that could compromise the adhesion of the tape. The tape should be applied in a spiral fashion, overlapping each layer by at least 50% to ensure complete coverage and a watertight seal. Special attention should be paid to joints and fittings, as these are often the most vulnerable points for corrosion to occur. In areas with particularly severe corrosive conditions, it may be necessary to apply multiple layers of tape or to use a thicker tape for added protection. The use of stainless steel or aluminum raceways is another effective method for mitigating corrosion in aggressive soil environments. These materials are inherently more resistant to corrosion than standard steel conduit, making them a suitable choice for applications where long-term reliability is paramount. Stainless steel raceways offer superior corrosion resistance compared to aluminum, but they are also more expensive. Aluminum raceways are a good compromise between cost and performance, providing adequate protection in many corrosive soil conditions. The installation of a cathodic protection system is a more sophisticated approach to corrosion control that involves introducing an external electrical current to counteract the natural corrosion process. Cathodic protection systems typically consist of an anode, which is a sacrificial metal that corrodes in place of the RMC, and a power source that drives the electrical current. The anode is buried in the soil near the RMC and is connected to the RMC through a wire. The electrical current flows from the anode to the RMC, effectively neutralizing the corrosive effects of the soil. Cathodic protection systems require regular monitoring and maintenance to ensure that they are functioning properly. Coating the raceways with a corrosion-resistant material provides a physical barrier between the RMC and the corrosive soil, similar to wrapping with tape. However, coatings offer a more durable and long-lasting form of protection. Common coating materials include epoxy resins, polyurethane coatings, and specialized paints that are specifically formulated for underground use. Before applying a coating, the RMC surface must be properly prepared to ensure good adhesion. This typically involves cleaning, degreasing, and possibly etching the surface to create a rough texture. The coating should be applied in accordance with the manufacturer's instructions to achieve the desired thickness and coverage. Burying the raceways in below freezing depths can help to reduce corrosion by minimizing the exposure of the RMC to moisture and oxygen. In cold climates, the soil below the frost line remains frozen for much of the year, which significantly reduces the rate of corrosion. However, this method is not always practical or feasible, depending on the depth of the frost line and the site conditions. The NEC mandates that electrical equipment be suitable for the environment in which it is installed. This includes protection against corrosion in corrosive soil conditions. Compliance with the NEC is essential to ensure the safety and reliability of electrical systems. The AHA has the authority to enforce the NEC and to require additional protective measures if deemed necessary. It is important to consult with the AHA to determine the specific requirements for RMC installations in corrosive soil conditions in a particular area. Understanding the soil composition is crucial in determining the best corrosion protection method. Soil testing can identify the presence of corrosive substances such as chlorides, sulfates, and sulfides, which can accelerate the corrosion process. Soil resistivity is another important factor to consider. Low resistivity indicates a higher concentration of ions in the soil, which increases its conductivity and makes it more corrosive. The pH of the soil is also a relevant indicator of its corrosivity. Acidic soils with a pH below 7 are generally more corrosive than alkaline soils with a pH above 7. The presence of moisture in the soil is a key factor in corrosion. Moisture acts as an electrolyte, facilitating the flow of electrical current that drives the corrosion process. Well-drained soils are less corrosive than poorly drained soils that remain saturated with moisture. The temperature of the soil can also affect the rate of corrosion. Higher temperatures generally accelerate the corrosion process. In areas with extreme temperature fluctuations, the expansion and contraction of the soil can also damage protective coatings and wrappings, increasing the risk of corrosion. Proper installation practices are essential to ensure the effectiveness of corrosion protection measures. This includes ensuring that the RMC is properly supported and aligned, that all joints and fittings are tight and secure, and that the protective coatings or wrappings are applied correctly. Regular inspections and maintenance are necessary to identify and address any signs of corrosion before they become a major problem. This includes checking for rust, cracks, or other damage to the RMC, as well as monitoring the performance of cathodic protection systems. When replacing corroded RMC, it is important to address the underlying cause of the corrosion to prevent future problems. This may involve improving drainage, modifying the soil composition, or implementing more effective corrosion protection measures. It is also important to use high-quality materials that are specifically designed for underground use and that are resistant to corrosion. In some cases, it may be necessary to consult with a corrosion expert to develop a comprehensive corrosion control plan. A corrosion expert can assess the site conditions, identify the potential corrosion risks, and recommend the most appropriate protective measures. The expert can also provide guidance on installation, maintenance, and monitoring procedures. The selection of appropriate corrosion protection measures should be based on a thorough assessment of the site conditions, the soil composition, the environmental factors, and the expected lifespan of the electrical system. A well-designed and properly implemented corrosion protection plan can significantly extend the life of RMC in corrosive soil environments, ensuring the safety and reliability of the electrical system. The cost of corrosion protection should be considered as an investment in the long-term performance of the electrical system. While corrosion protection measures may add to the initial cost of installation, they can save significant money in the long run by preventing costly repairs and replacements due to corrosion damage. It is important to weigh the cost of corrosion protection against the potential cost of corrosion damage when making decisions about electrical system design and installation. The NEC requires that all electrical equipment be properly grounded to provide a safe path for fault currents. Grounding can also help to reduce corrosion by minimizing the buildup of static electricity, which can accelerate the corrosion process. The grounding system should be designed and installed in accordance with the NEC and should be regularly inspected and maintained to ensure its effectiveness. In addition to grounding, bonding is another important aspect of electrical safety. Bonding involves connecting all metal parts of the electrical system together to create a low impedance path for fault currents. Bonding can also help to reduce corrosion by minimizing the potential difference between different metal parts, which can drive the corrosion process. The bonding system should be designed and installed in accordance with the NEC and should be regularly inspected and maintained to ensure its effectiveness. Electrical codes and standards are constantly evolving to reflect new technologies and best practices. It is important to stay up to date on the latest code requirements and industry standards related to corrosion protection. Continuing education and training can help electrical professionals to stay informed about the latest developments in corrosion control and to ensure that they are using the most effective methods for protecting electrical systems from corrosion. In summary, the requirement for wrapping RMC in corrosive soils is driven by the NEC mandate to protect raceways and fittings from corrosion. The specific practice of wrapping with 10mm tape is often dictated by local ordinances or industry best practices. Other protective measures include using corrosion-resistant materials, installing cathodic protection, applying protective coatings, and burying raceways below freezing depths. A thorough understanding of soil conditions and adherence to proper installation and maintenance procedures are crucial for ensuring the long-term reliability of RMC in corrosive environments. Remember to consult the AHA for specific local requirements and to consider engaging a corrosion expert for complex or high-risk installations. This comprehensive approach will help to safeguard electrical systems from the detrimental effects of corrosion and ensure their safe and reliable operation.